In this video, we will be talking to you about Newton's first and second laws. We will explain them in order, so if you only want to learn about the second law, skip to 45 seconds through the video. If you throw a ball in outer space at 20 meters per second with nothing anywhere near, how long will it take for the object to stop? That ball will actually never stop. It will keep moving in a straight line at a constant speed until another force is applied to that ball. Newton summarized this behavior with his first law, which states that all objects at rest stay at rest until acted upon, and all objects in motion remain in motion in a straight line unless acted upon. Objects tend to resist change in motion. This tendency is called inertia, and objects with greater mass have more inertia than objects with less mass.
Now we're going to move on to Newton's second law. Everyone who has ever moved an object knows part of Newton's law automatically. The heavier objects are, the more force is needed to accelerate them. It takes much less force to accelerate a toy car than it does to push a real car that is out of gas.
Exactly. So like I mentioned earlier in Newton's first law, objects with more mass have more inertia, and thus require more force to accelerate.
Right. And Newton's second law does more than just tell us this basic fact of the universe. It tells us the precise relationship between force, mass, and acceleration. He mapped it out for us in the following equation. Acceleration equals force divided by mass, or, as more commonly known as today, force equals mass times acceleration.
Now we are going to try a problem using that equation. For this problem, we first have to understand that weight is actually a force, unlike mass. Mass is the amount of stuff in an object, and weight is the amount of force applied by gravity to that stuff.
With that in mind, using Newton's second law, what is the weight of a 70-kilogram person standing on Earth? Well, we know the acceleration due to gravity, 9.81 meters per second, and we know the mass, 70 kilograms. So if we plug those values into the equation, force equals mass times acceleration, we get force equals 70 kilograms times 9.81 meters per second, which is about 686.7 kilograms times meters per second.
But a kilogram meter per second squared doesn't sound like a unit of weight.
That is because 1 kilogram meter per second squared is equal to 1 newton, which is a unit of force. And remember that weight is a force as well, so it can be used as a unit of weight.
But if I stepped on a scale, it would tell me how many pounds I weigh, not newtons.
Pounds are also a unit of force, and you can convert newtons to pounds. 1 pound equals 4.45 newtons. So if we divide 686.70 newtons by 4.45 newtons, we get 154.31 pounds.
Oh, that makes sense. So the scale is actually telling me the force gravity applies on me.
Yeah, which is the same as the force you are applying on the scale.
Okay, now let's try another problem using Newton's second law. Kate is sitting in a shopping cart when her friend pushes her with a force of 200 newtons. Her and the shopping cart combined have a mass of 80 kilograms. How fast does she accelerate? Pause the video and solve it on your own. We'll go through the answer afterwards.
According to Newton's second law, to find the acceleration, we use the equation a equals f divided by m. So insert the variables into the equation to get a equals 200 newtons divided by 80 kilograms. This turns out to be 2.5 meters per second.
All in all, Newton's first law states that objects have inertia, so they tend to resist change in motion. Also, heavier objects have more inertia. Newton's second law states that the acceleration of an object equals the force divided by the mass.